So guys, today we will discuss about the indexing method. In my previous class, we have already discussed the types of indexing method, the definition of indexing, what is indexing, the dividing head. Now, today we will discuss about the indexing method. By indexing, we mean division of the job periphery into desired number of equal division. It is accompanied by the controlled movement of the crank such that the job rotates through a definite angle after each cut is over. The following methods of indexing are commonly used. Number 1, direct indexing. Number 2, plain or simple indexing. Number 3, compound indexing. Number 4, differential indexing, and last is angular indexing. First, we will discuss about the direct indexing. It is the simplest case of indexing. Direct index. And what happened? It is happened in the plane dividing head. In the plane dividing head. As indicated there, the index plate is directly mounted on the spindle and rotated by the hand, and it can be used only when the number of division to be obtained is such that the number of slot on the periphery of the index plate is a multiple of the former. And the indexing ratio is n by n, where letter n is equal to number of the periphery, number of the slot on the periphery, and small n is equal to number of divisions required to be obtained. Let us see an example of this. Suppose if the circumference of the job has to be divided into 6 equal divisions, and the index plate has 24 slots, then the ratio is, we write the ratio is 24 by 6. 24 is my number of slots. Index plate has 24 slots, and 6 is the equal division. How many divisions we have divided? That is called 4 by 1. That means the index plate will have required to move 4 slots after each cut is over. That means after each cut, the indexing plate will move 4 slots. Another is, suppose 60 whole circles, calculate the movement 60 whole circles, and we divide to job is divided into 10 division. Then the movement is equal to 60 by 10 is equal to 6 divisions on the whole circle. Number 2 is plain or simple indexing. This method of indexing is used when the direct method of indexing cannot be employed for obtaining the required number of divisions on the work. For an example, if the work is required to be divided into 22 equal division, and the direct indexing cannot be used because 22 is not divisible into any of the whole circle on the direct indexing plate. Such cases, simple indexing or plain indexing we have all used. For this plain indexing, or there is a universal dividing head we used for plain or simple indexing. This method of indexing involves the use of the crank, worm and worm wheel, and also index plate. We have already discussed about the worm wheel, crank and index plate in my previous class. Suppose, and the worm wheel, we know that worm wheel is carries 40 teeth in the worm in a single start. Suppose the worm has single start thread and the worm wheel 40 teeth. Now, for the 40 teeth, the worm will rotate for 1 revolution, the crank, and the ratio is 1 by 40. Similarly, for 2 turns of crank, will make the work to rotate through um, 2 by 40 is equal to 1 by 20. Similarly, for 3 turns, for 3 by 40. Now suppose we want to divide the work into a number of divisions. The corresponding crank movements will as given. For 2 division, on the work, the crank will make 40 by 2 is equal to 20 turns. For 4 division is equal to 40 by 4 is equal to 10 turns. Similarly, for n division, number of division is n on the work, the crank will make 40 by n turns. Let us consider that the work has to be divided into 23 equal division, then the corresponding crank movement is 40 by 23 is equal to 1 in 17 by 23 turns. There is what happened for 1 is full rotation, 17 holes and 23 hole circle. Now example we have clear for a required 35 division on a plate. Find the indexing moment. There the required division is 35. That means it is not divisible with 40. There was a fraction. Let how see what happened. The required movement is 40 by 35 is equal to 8 by 7 is equal to 1 into 1 by 7. 1 into 1 by 7. Now what? This 1 into 1 by 7, this 1 by 7 is equal to, we both side 3 multiplied, 3 by 21. So the answer is, that means the answer is 1 full rotation, 1 full turn. This 1 is 1 for 1 full turn and 3 holes. This is denote 3 holes on, this is denote whole circle on 21 holes circle. Okay. Now next is compound indexing. Next one is compound indexing. This method of indexing is employed when the number of divisions required is outside the range. Then we can be obtained by simple indexing. It involves the use of two separate simple indexing movement and is performed in 2 stages. Number 1 stage is by turning crank a definite amount in one direction in the same way as simple indexing, and number 2 is by turning the index plate and the crank both either in the same or reverse direction. Thus they are adding further movement on the subtracting from the that obtained. What is the principle? The principle of the compound indexing can be best illustrated by taking a concrete example. Let us see what is compound. Let us consider that the crank is turned 3 holes on a 18 hole circle. The crank is 3 holes on a 18 hole circle, and that index plate and the crank both turn into 5 holes on 20 hole circle. On these two movements the worm will be turned. The worm will be turned what 3 by 18 plus 5 by 20 is equal to 5 by 12 of a revolution. Since the 40 turns of the worm turn and the work through one revolution we have already know, therefore the 5 by 12 turn of the worm will run the work. Therefore we know 40 turns of the worm turn the work through one revolution. Therefore 5 by 12 turn what 5 by 12 into 1 by 40 is equal to 1 by 96 of a revolution. This will enable 96 divisions on the work. This is 96. This will enable the 96 division on the work. This is my first operation. Let us consider second case. In the second case, what happened? Similarly, the second operation, index plate and the crank are rotated in a reverse direction to the adopted in the first operation. Suppose the crank is turned 5 holes on the 18 hole circle in one direction, and then the index plate along with and the index plate, and turn second is 2 holes on 20 hole circle in a direction of opposite to the former. Then the worm is equal to the worm turn 5 by 18 minus 2 by 20 is equal to, calculate this, 8 by 45 of a revolution. Now we use the worm movement, the corresponding movement of the work is equal to 8 by 45 into 1 by 40, because the 40 is the 40 turns for the worm turn the work through one revolution. This is the fixed, is equal to 1 by 225 of a revolution. Thus 2 to 5 divisions can be obtained on the work. What is the procedure? In order to obtain the required number of divisions through compound indexing process, the following factor is required. Number 1, factor is the number of division required. Number 2, factor is the second factor is standard number 40. Number 3, select for trial any two circle on the same plate and on its same side. Number 4 is factor is the number of holes of one circle. And number 5 is last, factor is the number of holes of the other circle. After obtaining these factors, place on as follows. There is an equation. Factors of divisions required into factors of difference of whole circle by factors of 40 into factors of first circle into factors of second circle. Okay, complete. Next is differential indexing. In principle, it is not very much different from the compound indexing, and it is also carried out in two stages. Number 1, that is first stage, is the crank is moved in a certain direction, and number 2 is second operation, is the second operation that follows either some movement is added to the above crank movement or subtracted from the same. But during the differential indexing, the index plate locking pin should be taken out free to rotate. The dividing head are supplied the standard sets of changing gears. The change gear supplied the brown and sharp dividing heads. This is the fixed 24 for two numbers, 28, 32, 40, 44, 48, 56, 64, 72, 86 and 100. In addition to this, some dividing heads are provided there with the following gears also. For the following gears: 46, 47, 52, 58, 68, 76 and 84. And the German made universal dividing machine, there is another sets of gear. we have not discussed about the German universal head. They are both simple and compound gear trains are used in differential indexing. But there is three types of gear change, compound gear train. This is called driven. This is called idle gear. This is also driven. This is connected with the this is worm shaft. This is main stud, and this is dividing head spindle. Dividing head spindle. Okay. In these gear trains, the first driver is always mounted on the main spindle of the dividing head. That means same spindle on the which mounted on the one wheel inside the job, and the last driven is mounted with the one spindle and which drives the index plate. The simple train consists of only the driver and one driven connected together through 1-2 idle gears. The use of idle gears and the consequent loss gain of most can be summarized as follows. Number 1, motion is gained by using one idler. Number 2 is motion is lost by using 2 or number idlers. This is using simple train. This is for simple train. And another is motion is gained by using no idler, and last is motion is lost by using one idler. This is for compound. This is for compound train. An example clear about the compound indexing. Find the gear combination and indexing movement for differential indexing. For differential indexing for 73 division. For 73 division, at first solution. This is my solution. At first we select 70 division. First we select 70 division. We select this 73 division. Say first we select 70 division. The simple indexing is equal to 40 by 70 is equal to 4 by 7. We use this 12 by 21, 3 multiplied in both sides. That means 12 holes on 21 hole circle. That means 12 holes on 21 hole circle. Now movement of crank for movement of crank for 73 division is equal to 73 into 4 by 7 is equal to 41 into 5 by 7. There is a fraction. Now that means 1 into 5 by 7 turns of the crank are to be lost through the plate movement. Now the gear ratio gearing ratio is equal to 12 by 7 is equal to 48 by 28. 4 multiplies in both sides is equal to driver by driven. Result: number 1, driver is 48 and driven is 28 is 28. Number 2 is simple train with 2 idlers, and number 3 is motion of crank is equal to 20 holes on 21 hole circle. That is my differential indexing. Last is angular indexing. We have seen during our above discussion that 40 turns of crank make the work rotate through one complete turn. That is 40 turns of crank make the work to rotate through 360 degree. One turn means 360 degree. Therefore, each one turn of crank, the work will rotate for each one turn 360 degree by 40 is equal to 9 degree. Now let us consider 18 hole circle. Let us consider for 18 hole circle. If the crank is moved through 18 holes on 18 hole circle, that means one turn will make the work turn into 9 degree. That means one turn it will make the work to turn through 9 degree. If it is moved 9 holes, that means half turn on this circle, the work will rotate through half above angle. that is 9 by 2, that means 4 into 1 by 2 half degree. Again, if it is moved 2 holes on the circle, that means 2 by 28 or 1 by 9 of a turn, and the work will rotate through 9 by 9 is equal to 1 degree, and the work is 9 by 9 is equal to 1 degree. Similarly, if the crank is moved only one space on 18 hole circle, the job will rotate through 9 into 1 by 18 is equal to 1 by 2 or 30 minute, half degree or 30 minute. Thus, we concluded that crank movement is equal to angle required by 9. Angle required by 9. Now what? We have decided that the simple indexing method can be easily used for indexing when full, half, 1/3 and 2/3 degree are involved. We discuss about the example for clear knowledge. Example: index for 3 degree 30 minutes. Solution. What solution? This is calculated by angular indexing method. So at first, what is my crank movement? Crank movement is equal to 3 degree. That means 3 degree 30 minutes. That means 3.5 minute. That means 3 into half by 9 is equal to 7 by 18 for 7 holes, and the answer is 7 holes and 18 hole circle. One we have discovered next index for 20 degree, 31 degree 20 minute. This is difficult, but this is 20 minute. What the ratio? 20 minute. That means the crank movement is equal to 31 into 1 by 3. 1 by 3 is equal to 20 minutes. That is 60 by 3 we use. That is 20 minutes. 60 by 3. If we use the 60 by 3, that means 20 minutes. This 20 minutes. That means 31 into 1 by 13 by 9 is equal to 3 into 13 by 27. That means 3 full turn and 13 holes on 27 hole circle and 27 holes circle. Complete. This is the 5 types.